Great.
Awesome. Hi, I'm Debbie, and I lead developer relations at Lit Protocol. And a bit of background about me. I used to be a software engineer, mainly in startups in the Bay, and then I got into education tech, so teaching a lot of different kinds of boot camps, setting curriculum for boot camps, and then made my way into Web3. And I cover everything for Lit, from hackathons to our grants to documentation. So if you ever see anything in the documentation that might need to be corrected, please let me know. It's always a work in progress. And so today I'm going to talk to you all a little bit about Lit Protocol. We're going to go through a bit of an introduction about what Lit is, as well as the programmatic signing product that we have. So Lit, the underlying kind of core thing that we think about Lit is Lit uses threshold cryptography in order to decentralize public key cryptography. So threshold cryptography is used to generate shares of a private public key pair in a process called distributed key generation. So this means that a private key never exists in its entirety ever, and it's distributed across the set of nodes. So each node holds a private key share, which they can use to both sign and decrypt data, just like a regular old private key. So rather than when we're on MetaMask, when we're on even a cold wallet, where we have full access to our private key, now that's abstracted away to a full network. And then from there, we're able to set access on who gets to sign with that private key, how they can sign. And I'll dive a bit more deeply into this. So two of Lit's core products, one is on encryption, which is kind of that read part, and then the secondary part is on signing. So right, on encryption, we think about that as information so that it can only be accessed by authorized parties. So access control really tying into that, and then being able to encrypt or decrypt information based on who has access. And then on that signing component, signing is writing data to blockchains, databases, storage networks, and other state machines. We can also think of it as when we're creating this like digital signature, or we're signing for something, we're writing information, or with the intention to write information. On the encryption side, Lit protocol, we're able to do on-chain conditions and credentials on things such as a user is a member of a DAO, user holds an NFT in a collection, they hold X amount of ETH, they own a specific wallet address, and you're able to do Boolean operations on all of those, above, anding, and oring any of them. And we support most EVM chains, Cosmos ecosystem, and Solana. So most of our technology is built around the ECDSA curve. So if there is a chain that uses the ECDSA curve, please, and we don't support that, please let us know. It's really easy for us to integrate that. And then on our secondary product, we think a lot about Web3 automation. So how does that occur with Lit for signing, or what we call programmatic signing? So through our programmatic signing product, there are two core components to it. One is our programmable key pairs, which are private public key pairs generated by the Lit network, and you can mint them in a form of an ERC 721 NFT, and whoever mints that NFT becomes a controller or delegator of who can sign with that programmable key pair. And then we have Lit actions, which are Lit's version of immutable JavaScript functions stored on IPFS. And we can think of them as smart contracts with these superpowers where they have network access and the ability to make arbitrary HTTP requests. So when these two components come together, they have the power to facilitate complex condition-based automation. So what if you could tell your wallet to execute a trade when your token fell below a specific price, or to automatically list an NFT when that collection hits a certain floor price? So being able to trigger an action using lit actions and then use a programmable key pair to do that signing. And for these two components, one question we get is, do we need a PKP to run a lit action? Not necessarily, but without it, the lit actions actually lose their capabilities of signing and decryption, because lit actions themselves hold that logic of, let's say you want to check some on-chain information and off-chain information, and then the programmable key pair is actually that signer that would sign for that information to say, like, okay, let's now kick off doing a swap of certain tokens. So together, they're really powerful, and we really encourage people to use them together. So some examples of how programmatic signing can be used is within infrastructure, where you can build oracles for off-chain data. You could build event listeners and condition-based execution. Again, that's like the bread and butter of lit actions, programmable key pairs, as well as building privacy-preserving transactions. We've had a grant come through where they actually did private on-chain voting using programmable key pairs and lit actions, as well as decentralized key custodians, where the network itself is a way to kind of distribute like it's a key management system. So thinking of ways to extend that. And then on the Web3 social side, being able to create credentialing systems for privacy preserving Web3 login, being able to work with account abstraction with support for Web2 auth methods, such as being able to auth through Google OAuth or a Gmail account and having an underlying Web3 wallet with that. So being able to onboard Web2 users onto Web3, or being able to recover social recovery, so recover accounts based on different attributes outside of solely having a wallet. And then a few others, decentralized chatbots, as well as verifiable on-chain reputation building. So how you can use Lit in your project is through the Lit.js or TypeScript SDK. And then I'm going to do a quick walkthrough of some of our documentation before jumping into some code.
Okay, yeah, I can see your browser up now.
Great. So this is the home of where the source of truth for a majority of the information that you'll need for building with Lit. So on our developer docs, we have an overview where you can get started quickly with different kinds of projects. We have a lot of example code. We also have a lot of examples about core concepts. So with that reading aspect, the encryption access control, there's a whole section just dedicated to being able to set access control, being able to set different kinds of conditions there, as well as going down, we have our programmable key pair concepts, as well as lit actions and how they work together. And then again, what I mentioned before is the main way to interface with Lit is actually through our SDK. So our TypeScript SDK is the main way that you'll be plugging in and calling the different Lit functions. And all of our examples should be up to date, so please let me know if folks run into any issues. And then I'm going to dive back into a little bit more about programmable key pairs and a bit more about how you'll mint one and then actually use it within an application. So I'm going to switch screens again. So we're going to get our first programmable key pair and then mint a PKP. There's a lot of screen switching, so I'm going to have to go back into, let's see, that tab. So I'm going to Chronicle, which is Lit's rollup, where we're going to go to our faucet and we're going to get some test tokens. Okay, actually, I skipped a step. Okay, I'm not a robot, and I'm going to put in my wallet address in here to get some tokens. Okay, so transaction hash. Okay, so let me switch to Chronicle, which is the Lit network. And this wallet actually already has a few Lit test tokens in it. And eventually, if you're going through this flow, you'll also get your test tokens. And then we're going to go on to actually the PKP Explorer page where we'll actually mint the programmable key pair. So let's mint one right now. Let's see. Okay, great. So I've minted a programmable key pair, and then let's actually view the programmable PKP addresses, because actually what we see up here, that PKP public key address, that's actually what we're going to use in our application. So we're going to use that public key to do the signing, and we're going to put that into different applications, and I'll show you in a second some example code and where a PKP would fit in. So the first example I'm going to show you, first I'm going to show you the UI before going into the replit. We're going to create a conditionally signed response using lit actions. And so this is going to use a lit action to check if the Ethereum, the ETH balance in your account is greater than the min balance that you set, and then sign it with that PKP. Let me go into the code. So first, actually, let's see. I'm going to start with actually that lit action code, which should be relatively straightforward, where we're actually going to create kind of this stub that says to call lit actions and like checking conditions. So conditions that will be passed in would be the balance of what we've set in, saying, okay, this is the min balance, as well as checking the wallet that will need to be checked. So the balance of that wallet, as well as auth sig and the chain that it's on. And what data that's going to be signed is actually just the min balance and that name that we put in. And to actually call the lit function, what we need to do is call lit actions.sign ECDSA which essentially calls the lit nodes to sign with to sign that information variable that we set before, as well as using that public key of the PKP and just creating a signature name, which will show up with that signing. So the lit action itself is relatively straightforward. And then later in this code, I'll also show you all how to check that wallet. So being able to say like, okay, I'm going to confirm, like I want to pass in this wallet information, as well as this is the PKP that we'll need to sign. So right here is kind of some basic setup around setting the auth sig, as well as instantiating that lit node client, which is how you'll work with the calling the lit nodes. And then execute.js is a really important function within using lit actions. That's how you will interface with the nodes themselves. In here, there's some parameters like code, which is where we are passing that lit action code, which is what we had earlier, and then an authsig, and then the JS params, which include this condition. So this condition format is actually taken from our access control format. And even in that previous workshop, I noticed like using access control conditions are really similar across different platforms. So if you were watching the previous workshop, this looks incredibly similar to that as well. And here, what we're doing is actually setting a condition of checking a wallet that someone's passed in. So getting the Ethereum balance, and then we're going to do actually a return value test. So that return value test is where we're actually doing that comparator, saying now compare this against this min balance that we have set. And then, so we'll set additional conditions that we're adding in: min balance, our name, authsig, chain, and then public key. What we get here is actually that PKP public key, our own PKP public key that we've just minted from the Explorer to pass in there. And so let's see if we can actually, let me grab that PKP public key and then put that in there. See, this loads. Okay. Okay, so let's say I want to have, this is a min balance, and this is my full name. And Replit sometimes is really finicky, so I'm hoping this will run. Let's make sure that I'm...
Pray to the demo gods.
I know, I'm always like, please, please, please.
Yeah, I know.
Okay, this may not run in the time we have, but I promise you this demo works. And I think one of the ways I think in the future we can avoid this is if I recorded a video and just played you the video of it working.
Yeah, it's one of the things you have, especially with anything blockchain related. We were talking on the last call about, you know, you hit the button and you wait and see and wait for the blockchain to tick away and get the result back. And sometimes these things can take a while. So
yeah. So okay, I'm gonna go back to the presentation then, and then go through a few more examples. So we saw the conditionally signed in kind of an arbitrary program using lit actions. And then additionally, another example that I just want to show you all really quickly is actually using Google OAuth to mint a PKP and then sign using that PKP. So being able to just log in with a Google account and then actually sign a transaction all through a Google account. We have some relay servers set up to take care of the cost associated with the transaction. And so being able to abstract away a lot of Web3 topics that might be really confusing to someone who's newer and being able just to onboard someone very quickly. So this will be less of a code demo and more of a resource, just showing you all kind of what's
So is that
possible.
that wallet abstraction? Maybe you're going to cover this now, but in terms of, so that's providing effectively gasless transactions to people using Lit, and is that a service provided by Lit that for doing that? Okay, cool.
Yeah, so awesome question. We actually, so we subsidize that relay server, and one thing that we ask of folks is to ask us for a key for that. So we'll subsidize if folks want to be generating programmable key pairs and onboarding people. We'll be doing that for like the coming future until at some point, I think if we're seeing like thousands to like hundreds of thousands of requests, we might be like, okay, now it's time for a different model. But for now, we're happy to subsidize that relay server. So here is actually a pretty in-depth article, which you can also check out the resources on the left-hand side of creating a PKP through Google OAuth, what the purposes of is of the relay, which is being able to do those subsidize those gasless transactions, as well as just signing in with Google and authenticating it, which is all related to actually how do we set different auth providers through programmable key pairs. And so like one auth provider here is Google OAuth. And then another one that we've been working on is like Discord, or you could set another wallet too. So PKPs themselves can have really rich abilities to allow access for who can sign with that programmable key pair. So it's not just an individual, it might be a collection or group of people may have access. So, and then this one, we do have a video for folks to also watch on their own time to watch the full demo. And then if you want to request access to that relay server, reach out to us about that. I think we also have all this code open source, and we have links all throughout here for people to check out the GitHub. Okay, and then let's see. And then going to our next part of this is how can Lit work with FVM? So the point of this hackathon, being able to work in Dataverse. So one example that I've been thinking a lot about is actually with data DAOs. So I have FVM, the example repo for a data DAO, example code of how someone might be able to spin up one pretty easily. And then this idea, when I was talking to some friends about what they were excited about building with FVM, I'll quote one of my friends here. I really want a data DAO where DAO members can create a lit key pair to manage shared data. It's sort of a 2 levels of access control, where Lit's key pair level control and the FVM's data access control that provide a lot of interesting flexibility and potential. So in this way, which I'll leave up as an assignment to folks throughout the hackathon, being able to do both together, so creating a data DAO and then potentially setting a PKP as an admin NFT, which allowing group access control through a PKP, or even allowing different nuances of how someone might be able to access it. So through a lit action being like, okay, if the, like another arbitrary example is like, if the weather is greater than 75 degrees Fahrenheit and this thing, then allow signing through a PKP. And so it can be like, I don't know, hackathons. For me, I'm like, the really fun explorations of how much we can push the boundaries of technology. So I really want people to have fun with being able to build with Lit and building with FVM.
Yeah, imagine that example use case you just mentioned. If you had Teller, which was one of our previous workshops, as a Oracle, so you could have data coming in from an Oracle, then being used in an access control with Lit to a data DAO with FEM. Wow. Okay. Yeah,
Yeah.
this is cool. Get some fun stuff, combining it all together. And a hackathon's the perfect place to do it, right? Because that's the whole point of a hackathon is to learn to play with these protocols, to kind of push, like you say, just kind of push the boundaries. You don't have to worry too much about commercial reality within a hackathon. It's a case of looking more at playing with the technology and what interesting things you can come up with the technology. So yeah, that'd be really cool.
Yeah, absolutely. Like I think of like a lot of these different experiments and being able to have these short experiments and being able to learn also within a context where for this hackathon, like I'll be the main point and main resource for Lit. So just being able to also have access to all these different really awesome companies and being able to have this direct line of, hey, I'm thinking of building in this way, or I really want to learn this thing. Like I can speak for myself and for a lot of the DevRel folks I know where we're just really excited that people want to learn and want to build.
Yeah, exactly. And access control, I mentioned access control is one of the things that people ask a lot about with Filecoin, right? And Filecoin in and of itself doesn't provide access control or encryption. That's left up to people to use other protocols, and examples like Lit and Lighthouse kind of show how you can do that. So that's yeah, it's really cool.
Yeah. And going into just wrapping up this presentation. So Lit, we're doing best use case of Lit actions and PKPs. So that'll be 2.5K USDC. And we're really looking for someone to utilize Lit actions and PKP. So that programmatic signing component, building that in with FVM and really thinking about also UI UX. And I personally really love tests, demos, documentation. So really also leaning into that too of how does someone communicate their idea and be able to like share that with the world. So having that experiment mindset with that communication mindset together.
Definitely. As I said earlier, please make sure you document how you use these technologies in these hackathons, because you don't want to anger Dawn, who is one of our judges, who especially will be on your case, right? Yeah, make our jobs as judges as easy as you can. Point out where you're using the technology and how you use it, so that we don't have to go searching for it, because otherwise there's a chance we might miss it, and we might miss something exciting that you've done. So please make it as easy as possible for us to see what technology you're using.
Yeah, and that is the end of my presentation. And thank you so much.
Cool. Thank you. Thanks ever so much. Thanks for that. And to everybody, thank you. We've had a great series of workshops today, and we will be back again tomorrow with a series. We have Mitrashish from Spheron, we have Dan from Tableland, and we have Sid from Polybase. So we have 3 more workshops tomorrow from some of the sponsors of the hackathon. So yeah, come on over and join in. And yeah, thanks a lot, Debbie, and thanks a lot to everybody in that came and joined. And we look forward to seeing what you're building. Okay. Thank you very much, and thanks to everybody from Filecoin Protocol Labs that have been in the chat, that have helped out as well. So Dawn and Carleen have been in there, and Nikki as well have been helping out a lot. So thanks to everybody, and we'll see you tomorrow. Thanks a lot, all.